Good evening, everybody, and welcome to tonight's stream. We have with us Chris Carson. Hey, Chris, thank you for joining us. And he has accepted a challenge tonight, and boy, what a challenge that is. Procedurally generated map in Fusion 2.5. Chris, how you doing? Why don't you say hi real quick?
Hello, real quick.
Excellent. Thank you for that mic check for me. Hey, before we get going, you know how it is. I've got to run my mouth just a little bit. If you tuned in, you got to see our live Patreon commercial. The Georgia Game Developers Association is a nonprofit organization, so please support our Patreon. Your support will help us with efforts to improve game developers and their community, as well as helping to bring better games to life. And I will learn to talk here in just a moment. Our stream is for gamers looking to learn more about what goes into making their favorite games, and it's for new designers looking to break into the industry. And it's for experienced designers, like Chris, looking to improve their skills, like making a procedurally generated map in an hour, or just over a roundabouts. Certain levels of our Patreon members will get access to join our live stream in vocal chat. Isn't that right, Andrew? He's not going to talk to us. Okay.
Andrew?
Oh, yeah. Hey.
There we go.
I thought you were trying to put the next thing into chat.
All right. That's all good. All right. So, as you see, we got a third member joining us in vocal chat who can pipe in at any moment. That's a certain level of our Patreon members can have access to that as we do first looks and all kinds of neat stuff. All right, next up, you see this awesome looking powerful shirt. That's right, it gives me a lot more HP. Our coffee cups will give you more intellect. All you got to do is go to cafepress.com/GGDA. Go out and buy something right now. That's not a request. All right, our YouTube channel. Everything that we stream here, we end up uploading permanently to our YouTube channel. So please be sure to go check out and follow our YouTube channel. And finally, the GGDA holiday party is December 12th. Woo! At Tripwire Interactive's new offices. Whoa. All right, if you know Tripwire Interactive, we were talking Killing Floor 2, Rising Storm. There's so many killer games. So join us for fellowship, fun, and festive Zed slaying. So, and also be sure, if you like games and if you're interested in game development, click that little follow button right here on the Mixer channel and our YouTube channel and tune in. All right. Say short, sweet, to the point. Chris, you ready to take over? Ready to take on a challenge of making a procedurally generated map within 1 hour, or thereabouts?
All right, so we're going to start doing this in a couple segments. My screen. Here we go. Just a press. And should be shared. Does everyone see the screen?
I am seeing the screen.
There we go.
Corlex says, I sees it.
Infinity. So here's a Fusion. I've preset an application up for the demonstration. A lot. I set my application width and height to 1136 by 640. The frame also shares the same dimensions. And I dropped a quick backdrop in, which we're going to expand out. So the first map we're going to make is we're going to make kind of a star system map, procedurally generated star system. That'll be our base, and if we have time, we'll try to do something a little more intricate with walls and stuff. So the very first thing we need to do in procedural generation, at least in my experience of procedural generation, is we need to get some numbers. That's right, numbers. And we're going to use, we'll go 64 by 64 size planets for this map. So let me just draw a single planet real quick. There we go. Let me go ahead and paint our little world here, a happy world. Remember, it's your universe. Have fun. Then when you're done, talk to squirrels in your backyard. There we go. And we should name it planets. And yeah, there's a reason why I said planets. We're going to use the same object for all the planets. And then I think we're good here. We don't want to create it at start. So yes, I said we got to generate numbers first. So we know that the height of our screen is 640 divided by 64 is 10. And 1136 divided by 64 is 75, so we'll say 17. So we've got 17 and 10 to work with. Okay, so first list we'll call second list we'll call vertical. Make that a capital V because we made a capital H. Got a trusty event editor. So I'm going to call a start a frame. Those numbers as soon as we start. And I'm going to call 2 fast loops. I'm going to start loop 1 that says generate horizontal. Copy that. So we won't need 100 of the numbers, but let's just generate 100. And then on loop, we have generate horizontal. Another fast loop in programming parlance would be a subroutine. Vertical. We will also do that 100 times. And we'll create an on loop. Vertical. So we have our horizontal and vertical list box. And then you'll see here I've added an object called randomizer. So what randomizer does, it lets us set a seed value. So we'll set a random seed, and we'll just say 100 to start. 101. Okay. And then we go ahead and we're going to add a line. Then we're going to create a string because we're entering text, but we're actually going to pull numbers. So we need to do the string conversion. And say, give me a random number in a range. So the initial number would be 0. And because this is horizontal, 10. Let's run it and see what we get. And now we get a list all between a range. And they're randomly generated based on the seed value. Over and over, you see that I'm getting different numbers, which is not supposed to happen. And the reason why that's happening is because Fusion is still running, and so it's still accessing the same seed base and appending different numbers. So that was a poor demonstration. So if I run it again, we'll screenshot our numbers. We'll put that bad boy over here, and then we'll turn it off, run it again. Have the same numbers, and for some reason we don't. And this is what I love about programming. I don't know I don't care what you're programming in. I don't care who you are. Programming is the first half is coming up with this incredible, amazing stuff, and then the last half is fixing everything you broke, which is what I just did. I set my random seed after I generated the numbers. If you don't input a number into the number generator seed before you generate numbers, it randomly generates numbers on its own. So if I run it now, should have every time I run it. This is important when doing generation. And there we go, identical numbers. Because worlds, planets, systems, maps, whatever, just on a seed number, which is pretty cool because then you can number and always load the new map, and it will always be the same map, if that makes sense. So let's see if at this point we have any questions, so I don't repeat it over and over again. Game programming is always about making computers do something no one else has. Oh, okay. Yeah, that too. All right, now we got to do the same thing with our generate vertical numbers. So I'm going to just drag the event over, but the range is different for 10. So as vertically, it's 640. There's only 10 spots a 64 by 64 bits pixel sprite could fit, and we don't want any of them overlapping. So the next fast loop we'll run is minutes. And well, let's start with just 10 planets. See where that gets us. Make a planet. Now what we'll do is we will create planets. And we're going to put it off screen rather. So we'll just put it here. It's 64. Make it negative 64 by negative 64. So it does not appear popping in onto the screen. We want it to immediately drop where it's going to go. And we do that here. Coordinate. And we know it's 64 pixels. So we got to multiply 64. And we start with the horizontal, because that's what X is. And we get line. But I got to convert that line into a value. And the line number will be the loop index that we're on. Loop indexes in Fusion are zero-based. List object is zero-based, and I think they now default to one-based. I need to add a 1. Let's see what that does. And that may simply be because we haven't placed them at X. I mean, we placed them at X, so they're appearing at the top. They're appearing up here in a random X position, but because we started creating them here, depth. So that's the next line, which is not that hard. Position, set Y position, and just like before, 64 times. We're going to get line. The line is loop index, make planet, plus 1. Now we get planets. And every time we run it, we get the same system of planets. Do extra, right? We could start by creating different types of planets. So let's say we have, we'll give each planet different colors. Green planets, yellow planets, deep blue planets. This with the lighter blue planets. Magenta planet are no joke. And all the tax auditors live on the gray planet. Planets, and when I said we have 7 planets.
Please tell me we can blow up that planet. Sorry.
Oh, this one? You want to blow this one up?
Yeah.
So images in Fusion, in an animation, in a active object, are zero-based. So even though it says frame 1, this is actually frame 0. So let's remember that it's zero-based. 1, 2, 3, 4, 5, and 6. Now, when we generated our numbers, you'll notice that zeros were included. 0 to a max of 16, I believe, on this one, and a max of 9 on this one. 0 through 6. So what we need a new fast loop, planet type, we make the appropriate fast loop, planet type. And again, we can do 100. It's a pool of numbers that we're putting in a list object. We will rename this one to planet type. Tile. There we go. Just like before, generate. This time it'll be from 0 to 7. 0 to 6 numbers. Let's make sure that it in fact does that. We get 0 to 6. So, on this planet that we created, now we're going to go to animation. Change. Animation frame. We're going to line. Then we're going to which iteration, and we're going to call that make planet. I forgot my quotations. And we +1 it. And of course, it says still syntax error or numeric expression because this is text-based. We have to convert it to a value. Should that have been done right? An error. And the error is I made my planets before I generated my planet type. In Fusion, if you want to see what the main loop looks like, you can look at it with this view here, the event list editor view, and you can see that here are my main line numbers, and then the conditions or the ifs are, and it operates in order. And before I generate planet type, then yes, all the planets are going to be 0 or the blue color. So by switching it that way, we should have it debugged. Run it, planets. And every time I run it, I get those different planets. Now, we can add a, see how the seed value works a little better. So edit, right. We'll drop that edit box here. Tests. We're going to hide them. Put them off screen, get them out of our way. B for button. Come on. There you are. Right. Generate. What we do now is we will say we're going to destroy all the planets. We're going to reset the lists. Change the random seed to a value of whatever number has been typed into here. Execute all our fast loops. We'll look at the order to make sure we did it right. Looks good. And so it starts with 100, and then I can type in 999 world. Now, it didn't seem to destroy the planets for some reason. Let's confirm that. Simply by deactivating this line. It's not clearing out the previous planets for some reason. So it could be just a tricky thing in Fusion. Because I'm calling fast loops, it may not catch the destroy. So let's see if that worked. There you go. Created very basic procedural generation based on a seed value. Take us to do that, 18 minutes. Not bad. So, let's see if anybody has any comments for me. Little world, yes, that no, I do appreciate a happy little world. Okay, and he's going to make sure I get the questions, and apparently we've had none.
There was one that said, if we're going to generate them for X, Y, and Z, can we also generate their position in time?
I mean, you could, yeah. So, I guess the question is, what does he mean by in time? If you're doing, do you want them to appear at specific times, or do you want them to, you know what I mean? What is that? What do we mean by time?
I'm guessing he's probably meaning like randomly appearing within a time frame, or unless he can. Here you go. Here he is.
Right. So it started as me thinking about it. We could generate them on the X, Y, and Z axis. We could also then generate them on the fourth dimension, and if we did that, we would have them coming in and out of existence.
No. Yes. Maybe.
Could you hear us?
I didn't hear anything.
Oh. Okay. Whoops.
Test, test, test. Test, test, test.
Do you not hear Andrew?
Test, test, test. Hello.
Yay, technical difficulties. All right, let's step back. Chris, can you hear me? All righty. All right, we may have lost some vocal communications somehow. Chris, are you still with us? Can you hear me?
Yes, can you hear me?
Yes, I can hear you. Could you hear Andrew when he was talking?
No.
Try it one more time, Andrew.
Hello, hello. So my comment began with kind of a goofy thought that if we could generate a world X, Y, and Z's coordinates.
Nothing coming over here.
All right, he cannot hear you for some reason. That is kind of crazy, even though we're all in the same voice channel.
Well, anyways, I'll just keep tooling away.
Maybe type out your comment, Andrew, and he can keep on going.
So I'm going to do some comments here. Yes. And then we still could copying this event, dropping it here to start a frame, and setting the randomizer to a specific value. We could go back to generating an initial system. Generate. Another thing you could do is by using ASCII, you could convert text from ASCII into values to be the seed value, which is really cool if you wanted to, you know, have someone travel to Andrew's system, and then, you know, the player could type in, well, you visit this system, and then that system's set up a certain way. And of course, we're doing very basic procedural generation here, but you could make it as complex as you want. One thing I want to do is I did drop an array file here, and I figured we could save the data while we're at it. And the way we're going to do that, knowing that we have a 17 by 10 dimension array, I'm going to, the solar system, I'm going to create a 17 by 10 dimension array. The ways arrays work in Fusion is they only work in the positive. You can't have negative X position or negative Y position. But if I was to start writing to position 18 on the X, as you can see, there is no 18. It limits to 17. It will automatically expand. If you have a 3D array, meaning that you have several slices down, and you expand a slice down, it will expand all the rest of the slices. So you can always push out the array. You just can't go into the negatives, which is why when I did Bit Odyssey, I wanted to make the procedural generation endless. I wanted you to be able to explore endless amount of stars. So what I did there is I created a deep array, and each layer of the array represented a quadrant. And if you were in your map position, which I stored in a different storage object, in the negatives, either X or Y, or both X and Y, it would then switch you to one of those four arrays, and using absolute values, switch them back to positives, and allowed me to push out further. So what we're going to do is we're going to store all the data that we create in our planet, which we need planet type for value. I keep typing tile. What is my deal?
Gotta love dyslexic.
That's like Steven with an H.
Just to
Steven with an
clarify
H.
with you, if you can hear me, can you hear me?
Oh,
Hey, Chris, could you hear me real quick?
yes.
Hey, all right. Just to clarify what Andrew was talking about, he said his thought was that if we could generate the world's XYZ coordinates, we could also generate its coordinates on the fourth dimension, being time, and have planets come into and out of existence. This would be interesting for a millennia-spanning game like Spawn.
Yeah, I mean, you could do that. You would have to, now, in Fusion, we're spawning the objects at the beginning of the game, so you would have to either spawn them at the beginning of the game, and then if you're making a 2D game, hide the sprite until the stored timer time triggers when it's supposed to appear and when it's supposed to disappear, and then make it vanish again. So yeah, I mean, you could do that, or you could write a less effective routine, which would create the time and random times in and out, and then have to scan consistently your array to see which ones match the current time to create. I think doing it the other way around would be better, because then you're not consistently pinging a data source. Objects outside of your application, doesn't matter what you're in, it starts to tax your resources. And writing any program on any system with any language, you want to manage your resources as best as possible. So that being said, I was actually creating some create in our planets. Next one I'm going to create is, so we got population, planet type. Give me a third value that we might want to. Anybody?
9.
9 is in no.
That material.
Material.
Corlick says material.
Okay. Material. So we got material type, we got planet type, population, and material type. Now, what we're going to try to do is we're going to try to generate, when we make planet, the additional values that we need by using the same command when we generated our lists. We'll copy the random range expression, and then on our create planet line, we're going to go on the fast loop. We're going to go to, where is it? Algebra values, set random range. We'll say 1,000 to 9,000. And then we could do the same thing with material type. Materials 0 to 4. Do to test to make sure that works correctly is we're going to grab a string that we'll use for testing rather. Drop it here. Black is obviously not a good color choice. Stretch that bad boy out. Then we're going to add a testing condition that says over an object, and that object being one of our instances of a planet, then please pull data from it, and the data we want, population, and we'll separate it, and we also want to pull the material type number. So planets, material type, population, and material type, and then we run it. Didn't work. Oh, that's because it's click. I wanted it over. Check for mouse over an object. There you go. So that's 3, 2. Of course, the population should be a number in the thousands, so we need to figure out where we went wrong there. And there's the bug. I'm setting the population again to the smaller number when it was supposed to be material type. Programming. Mistakes you made. There we go. So we can see that the red planet on this seed, 1,147 population. Let's rerun it. Same population. Let's add a different seed. Let's check out the purple planet, 5,513. 5,013. Change the number. Got a purple planet over here with a totally different population. So now, with procedural generation and a random number generator, we're actually creating content. Okay, now we need to store that data, right? So let's create our save routine. Start a comment. The data. We know that we generated X number of planets on the map, which should be a total of 10. And what we're going to do is we're going to say on the keyboard, when pressing S for save, we're going to run a fast loop. save my with a Z. And we're going to run that based on the number of planets we generated. So we're going to create that first loop on fast loop, planets with a Z, and we're going to identify one planet. We're going to pick one at random. We're going to write value. We're going to write a string to XY. Okay, and the string we're going to write is we're going to write string the population. Then we need a delimiter. And then we're going to do string material type. We also need string animation current frame. Whatever frame it's been locked in on. So the data that we're going to store in the cell is the current frame it's being forced to, which is the planet type. Then we're going to have a delimiter, and then the population number, and another delimiter, and the material type. We hit OK. Where are we storing it? Position, an XY position for the object. So we should be able to say, give me the X position of the planet, and because we multiplied it by 64, divide it by 64 to get a value between 0 and 17 for X. And then we'll do the same thing for Y. We did it right, the proper data in our array object. And after we're done, we need to save the array. So let's file, I'll use an expression, and we'll just say my planets array RR. Now, the problem with that is it doesn't tell me exactly where to put it, so I'm going to use expression here, which locates the root directory of the app or wherever it's running. Looking good. And then we need to destroy the planet that we're reading. That way we only pick that planet once. So I need to save this. So we'll create a new folder temporarily here, and we'll call it procedural generation. Dump it in there, application 2, that's fine. And then I need to find that folder. Motions, Fusion Wars. And so there's no array file here. We run it. Generated our world with our data. We hit, I believe it was the S key. Yep. It wrote the data, and let's see if we have a file. And there we go. We have an array file. To load the data. So instead of generating one of those random worlds, we're going to add load the data. Let's start a frame. Drop that between here. We're going to first load file, which best way to do it is to copy here. There. We're going to file, load array from file, use that expression, location. So we're loading and saving to the same location. Then we know that we're going to have a maximum of 17 our X and 10 Y. So we're going to do a nested loop, and we're going to say fast loop, load X planets. Do that 17 times. Next one has a question. Someone has a question, or was that someone having a question?
No, GGDA asked at one point how many Doom stars in orbit over each, but you're moving right along just fine.
All right. Where did I do with my starter frame? There it is. So, X planets Z, which will load our columns, if you will. And then every time we run that, we need to run Y, loop, and it's load planets, load Y planets. And that's where the nested loop comes in. We do that each time 10 times. Things is, when these loops execute, first 17 times, and the first time it runs, it pauses and runs the next loop down, which is the Y planets, which execute 10 times, and then we go back up to. That's great. So loading data, we're going to create an object on the load planet Z. It's going to be our planet again. Probably just steal that event, change it, and then we got to change the data here. So instead of setting X position to the formula from our data pool from read value from XY. No, it would be. Mind you, I'm doing this. I'm thinking about this as we do it. So if I pause, it very well could be because I'm stupid, but it's because I'm thinking.
I don't think you're stupid. Far from it.
64, and then we go here. A x coordinates to the loop. And we need to get the fast loop. Which is load X planets. Okay, that gives us our X coordinate. And then we're going to set Y position but to Y. Now, there's an issue with this. That issue is, what if there's no planet on that cell? I'm going to create a ton of planets no matter what I do. We need them to create the planets at the proper cell numbers. So there is a solution to that, and that's where our friend the string parser comes in again. So I'm going to do hello work. I'm going to set source string to my position, and we use those fast loops again. In there, no. So XY load X planets z. Let's copy that. Y. There we go. So now we're asking how many X, we're asking the string parser to load the data that's in that cell. In here, and we say compare two general values. We get number of elements. Is it greater than 1? A array, when an array reads null data into a string parser, it will return at least one element, because elements are the data between the parser. If there's no parser, it defaults to one element. So we want to say it's greater than 1. So if that worked correctly, it didn't. We're not reading the data, apparently. So now we got to do some more testing. Who loves testing?
Yay, debugging.
Debugging is fun. All right, so that string, and we know that we wrote data to that string when we saved it, and that contains the same data, and see if it returns anything. And you can see that I have, oh, there's some data. Data 1. Okay, so there's data there. So this isn't working right. So let's change it to list count. Let's try elements instead of elements. Number of delimiters is greater than 1. Let's see if that returns anything. Still nothing. It's a bit odd. Okay. And what we could do is on our test line here, line, see if it's writing anything. Let's see if it's even triggering. And so that line's not even triggering. So we'll put that back up there. So the error we're having is here. So number of delimiters is greater than 0. Let's see if that gives us anything. Still nothing. Ah, it's you know. Good. Let me back it up a bit here. You know why it's not working? Because I haven't let it know. How can it tell me how many delimiters there are if I don't give it the delimiter? Duh.
D lovely.
There you go. Planets have their populations. Just as well, we have those. I think those are generated random numbers. So we need to continue to pull the right information. So now what we're going to do is set this to value. We're going to get element 1. Copy that over. And then element 2. And then element it's magic. This was based on, I don't know what seed value it was based on, but let's just put in 999 again. Generate. We know that this planet has 6,557 population and 0 material type. Sure that is consistent. It is. Now we can save. Then we'll run it again. And what happened? Anyone want to guess what just happened? The population is right for this extra planet, but the planets from the previous seed are still there. Question as to why that happened. Well, I'm writing into the array the new spots. And in the array is still the previous data. So we have to clear the array first. That should solve that bug. Generates, I don't know, there you go. Get this picture here, that being a population of 3,900. We save it. And we run it. I will write over it. Save it. Run it. So, any questions so far?
There was one that was from GGDA once again. He says, nice planet characteristics. So how about an economy generator based on how far away the planets are from each other?
Yeah, sure.
All right, so do I need to read the rest? Okay. For instance, if one planet sells dilithium and another sells midichlorians, they could each buy and sell for a default of 100 GP latinum. However, the further away the one gets from the other item source, the price goes up based on the XY difference between them. It seems kind of...
Okay, what I love about programming is my experience working in the oil industry is you have people who don't program think up ideas. And and they expect it to be the easiest thing in the world. And what I've found funny is that the things that you expect to be easy end up being the hardest, and things like Andrew just suggested, which, off the top of your head, wow, that seems pretty complicated, end up being pretty easy. So I'm going to hold my tongue and say that that's not something we can't do. I think we're going to do it. We're going to try to do it 15 minutes. First thing he said is distance. An object that will calculate distance. So we'll use the advanced direction object. Okay. You get two objects to do distance with. So this one we will call click 1. Our objects we call click 2, and Fusion is going to automatically number it for me. Fusion is just so friendly. I love it. Okay. Now we're going to repurpose our test list into our items list, and we got Schmeg. We've got let's see, Greenberg. Right. Element very popular in the universe called Miller time.
Gotta have it.
Right. And then how many product types did we say we had? All right. It's got to match. We're going to have the same amount of. We do. Anyone remember how many item types we were making? Let's see. Generate planet type, and then down here. So material type was 4, 0 to 4, which would give us 0, 1, 2, 3. That's 4 material types. We've got 4 material types. Oh, man, I can't believe I just did that. There you go. 4 material types. Great. What we're going to do now is we're going to build our clicking system. And we're going to say click on planets for comparison. Okay. I'm going to grab my favorite object of all time. Irritates people all the time when I do this, but this is my local value storage object. Go ahead, laugh. That's fine. I'll drop that bad boy down here. Variable, which is click step through. Right? And we're going to say if the user clicks on an object being one of the planets, position, click 1 on the planet, 1 to step through. So far, is that fair? Miller, is that fair? Is everything I've done up to this point fair?
I would call fair, yes.
I'm trying to sound like Chris Angel, the magician.
Ah.
All right, do you? All right. So now the reason why I didn't put, the reason why I did these recursively is if I put this event above here, when I click on the object and it's 0, I add 1 to 0, I'm still clicking on an object, it would treat this one as a trigger too. But by recursively placing them in order so that they're kind of backwards, it erases at the bottom of the main loop I click on. Does that make sense? So that when I go back, the next object I click on is a new click. So let's do one thing real quick. Our selectors, so we know that we're selecting different. Blue. Now let's go with orange. And with a brighter orange, because I don't believe we used orange in any of the planets. And then we got to make sure that they are always on top. Top. And then, so now we've identified 2 planets that we want to compare. Now we have to figure out what. So I'm going to grab 2 new string objects. clone these 3 times. Well, we'll just do 2 because I don't need the test one right now. Is we're going to click on that planet. We're going to say position, select position near to the planets, right? And then we're going to change the optimal string to the line relative to, and then we're going to do actually that here and then this one here. Have I done it right? We should get the different product types. Let's see, this one, because I got rid of my test string, I can't tell which is which. We need a test string again, it looks like. Clone here. Okay. And always for our test string, change ultimate string. And it's we just need the material type right now. Okay. Good. Then I think here I'd like to offset it a little bit. We'll do it like this. And we duplicate that down here. Identify which one we're doing. So it's mouse over planets. And this has got a material type of 1. This has a material type of 1. Click on this one. It's Miller time. And if I click on, it didn't bring the product over. So that's interesting. Could be because it's 0 based. If this one is 3, yeah, see, when this is 0, okay, so what happened there is that we have a 1 based versus a 0 based. So the material type is 0 based, but the list is 1 based. So I need to change the offset. And 1. So then be Miller time anymore. It should be Kistagurium, which it is. So now we've identified what products are on each planet. And then because we're running short on time, this bad boy for clip step through, and we need to figure out the distance. So we could just real quick say string give me, and we use that distance object here. So we're going to go no decimals. We grab the XY points of the 2. Okay. Get to step 2. See that these 2, how far apart they are. Because I got the wrong click step, it should be 2. So 63 parsecs apart. So if I wanted to transact between Kistagurium and Greenbergithium, they have 263 parsecs to traverse, which we can use our calculation. The other thing we'd have to do is identify in another list values. I haven't really written much on exchange rates, so I guess we could start with a value for each. 10, 20, 30, 40. Got our values there. And we could say that the first person is trying to sell. Yes? I don't know how we would do the. I'm not good with my economic formulas, but we did do it that way. A plus R6 A it costs we can sell, right? We can sell. We'll say string plus four. And we'll stop there, as we got to do another step. To the step, I don't have an isolated object. Now, what I could do, insert, collision, overlapping. I have isolated down to one planet that I can pull numbers from, which means I can go into here, plus, and then I could say we need to get value, get line based on material type, and we could say more, right? So we could say divided by, then we got our distance calculation here, and we're going to get a bad number, but it'll be a number nonetheless. 163 parsecs, we can sell it for 0, and that's because these values divided by the distance don't equal a proper positive number. So we just slap a bunch of zeros in front of these for right now. Still nothing, so there's something wrong with my formula. Fine. Probably because I should divide the distance. That. There you go. 515 of measurement, Mr. Miller. What's our unit of our monetary measurement here out here? There?
Yeah. Oh, I'm sorry. What are we calling it? Not gold.
Yeah, we got to have money for this universe we're creating.
Not gold. I don't know. Mice.
Solenoids.
Okay, solenoids.
Rich on them solenoids. So it's not exactly what Andrew asked for, but we did calculate distance. We did find out what product I have and how much it would cost for me to sell it here. Now you could go further and figure out what the cost of the materials are here, do an offset. There's all sorts of things you can do, but once you have the distance measurement and the ability to isolate the two planets, it's real easy to do. So I hope that answers Andrew's question. We got it done. We got it done in an hour.
I'm floored.
Basic procedural generation.
Wow, I am absolutely floored, dude. This is amazing.
Well, let's see if anybody has any comments.
Yeah, no comments as of now. We've been having some viewers pop in and out throughout the night, but I gotta tell you, this is some YouTube gold, especially for future viewers who couldn't make the actual stream tonight. So,
okay.
I mean, wow, dude. Virtual high five from Georgia to California.
High five.
Yeah, this was absolutely amazing. Let's see, what am I doing here? I am going to quickly go through just our a few announcements. One of the things that I forgot to mention at the beginning of the stream, so everybody can see my ugly head. Here we go. That. Yes. Hi. There's all right. Something we forgot to mention at the beginning of but you did show a couple of things. Fusion Wars Game Jam. Chris, you want to talk a little bit about it? I'm going to throw a link right here.
Sure. Oh, thank you. So we're going to do another Game Jam this December, and we're calling it Fusion Wars, the Programming Menace. Game Jam. And basically, as traditional programming threatens to quash creativity in the galaxy, Fusion must come to the aid of developers and give the power of programming back to everyone. Jam far, far away, but let's be honest, it's just at your desk. And help us save the galaxy by building an awesome game in 2 weeks using Click Fusion, and win some awesome prizes that we'll announce soon along the way. To the script side.
Hey, all right. So, hey, explain your image there. You got to explain that one because you told me
Oh
a
yeah,
little bit about it.
so it is you know, what was Darth Maul is now Nico, who's our artist, and of course he wears glasses. So this handsome young fellow here is our founder Eves, and if you grab the poster from the original Star Wars, that's a totally different face. I got to give Nico super credit. I looked at it the first time and I'm like, did you change the poster? And then you look at it and you're like, oh yeah, holy smokes, he did. This is Oliver, another one of our artists. If you look closely at this, that is not Obi-Wan, that's Danny. And you look closely at this, that is not Padme, that is my daughter Taylor. And of course, this isn't a spaceship, this is Eves' Renault. So there you go, that's our parody poster about the contest. Yeah, check it out. Another thing that would be great for you to check out is I stream every Friday. Reactor. The Reactor is like a membership service for ClickTeam users where you get awesome free stuff out of the store every month. A ton of free examples like the one I just made is posted exclusively just for those users. And we stream every Friday, and all the content I made is user generated, so you tell me what you want and I make it for you. Just 2 weeks ago, and I did an inventory system last Friday.